We are building off of what we did yesterday with terminating decimals to now talk about repeating decimals. One thing that I want to go ahead and talk to you about real quick at the top, though, is sometimes we are going to get a fraction or division problem where 0 is involved. If we have 0 divided by any number, meaning 0 is listed first or it's on the top of a fraction, our answer is going to be 0. So in the example I have to the right, we have 0 divided by 6 equals 0. So think of it like this. If you have 0 pieces of candy and you want to split it up among 6 people, each person's going to get 0 pieces. However, in our next bullet point there, if I start with any other number and I divide it by 0, so 0 is second or it's on the bottom of a fraction, our answer is going to be undefined. Basically, that means we cannot do it. It's impossible. Here's how that works. In my example to the right, I have 11 divided by 0. So let's say I had 11 pieces of candy and I wanted to split it up among 0 people. How many does each person get? That's impossible because at least one person has to have the 11 pieces of candy. Those 11 pieces of candy don't just vanish into thin air, but I also have no one to give them to or no one to have them. That's why it's impossible. The next thing we're going to talk about is repeating decimals, how we recognize them and how we write them. So a repeating decimal is never going to end. So they're not going to terminate in zeros like the numbers we talked about yesterday. They are going to have a pattern though. Sometimes you'll see it with the 3 dots at the end, or more commonly, you're going to see it with a repeating bar, and that's what we're going to practice writing them with. So in the next couple examples below, we're going to practice writing these decimals with the repeating bar over the correct numbers. In my first example, I have 0.123, and it keeps going. The pattern that was established is that the 1, the 2, and the 3 repeat. Since all of them repeat, I'm going to draw a repeating bar over all 3. The 0 does not repeat, plus it is in front of the decimal, so I'm not going to put the bar over that. Looking at my next example, I have 5.62222, and so on. In this example, the only number that repeats or continues is the 2. So when I draw my repeating bar, it goes over the 2 only. In the next example, I have 7.1145454545, and it keeps going. In this problem, the 4 and the 5 repeat, but no other numbers, so the line only goes over the 4 and the 5. Finally, I have negative 1.05050505, and so on. That means that since the 0 and the 5 repeated, a line goes over both of them. So I want you to look at the next part below. We're just going to practice being able to identify whether they are repeating or terminating. In the first example here, I see that that 9 at the end has a repeating bar over it. That means that this digit or this decimal is a repeating decimal. However, in my next example, I have 0.2. It stops, there's no pattern, it doesn't keep going. Since it stops, it's a terminating decimal. 18.35, again, no bar over any of the numbers, no dots to show that it continues. It stops, it ends, it's terminating. Finally, I do again see a number that has a bar over it. When I've got that repeating bar, that means it continues, and therefore this one is repeating. When we go to turn our fractions into decimals, we're going to do them basically the same we did yesterday. We're going to convert any mixed numbers to improper fractions. We're going to set up long division, so our top number is going to go on the inside or underneath. Remember, it's not about which one's bigger, it's about the order. Top number on the inside, bottom number on the outside. Then we're going to keep dividing until either we have a number that terminates in zeros, like we did yesterday, or what we're going to focus on more today is if we notice a pattern. That pattern is going to tell us it's a repeating decimal. One thing that's going to help us notice a pattern is we're going to keep getting the same remainder when we divide. So we've got 3 examples to practice with. I've got 1/6. The first thing I'm going to do is set up long division where top number's on the inside, bottom number's on the outside, and I'm going to add a decimal and a 0 behind that 1 because I know I'm going to get a decimal as an answer. 6 cannot go into 1, so I could say it goes in 0 times. But 6 can go into 10. It goes in once, so I'm going to put a 1 on top of that 0. 6 times 1 is 6, so when I subtract, I get 4 left over. Since I have a remainder still, I'm going to add a 0 and keep going. 6 can go into 40 6 times. 6 times 6 is 36. When I subtract, I get 4 left over. Add another 0 to bring down. I just did this. 6 can go into 40 6 times. With 4 left over, add another 0. 6 can go into 40. What you should notice at this time is I've gotten the same remainder 3 times in a row. A pattern has been established. The thing that's going to keep repeating is this 6. So when I write my number, I'm going to put the 0.16, but when I write my bar, the only number that continues is the 6. So the line goes over the 6 only. My answer is 0.1, and the 6 repeats. For my next problem, I have 5 2/9. This is a mixed number, so the first thing I'm going to do is write it as an improper fraction. That's where I do bottom times the whole plus the top. 9 times 5 is 45, plus 2 is 47. I'm going to set up my long division. Top number on the inside, bottom number on the outside. I know my answer is going to be a decimal, so behind that 7, I'm going to put a decimal and a 0. 9 cannot go into 4, but it can go into 47. It can go in 5 times. 9 times 5 is 45. When I subtract, I get 2 left over, and I bring down that 0. 9 can go into 20 2 times with 2 left over. I don't quite have a pattern yet, so I'm going to add another 0 to bring down. 9 can go into 20 2 times with 2 left over. Now, 3 times in a row, it's definitely a pattern. I had 2 left over, 2 left over, 2 left over. That means my last digit that I was writing on the top is repeating. So when I write my answer, it's 5.2, and the 2 is what was repeating. That's what I kept getting on the top there. So it's 5.2 with the line over the 2, or the 2 repeats. Last question. I have 17 over 33 with long division. 17 on the inside, 33 on the outside. Again, it's not about the bigger number. It's about the order. Top number goes on the inside. Behind the 17, I'm going to add a decimal and a 0. And I'm going to start my division. 33 cannot go into 1, and it cannot go into 17. So I'm going to say it goes in 0 times. 33 can go into 170 though. When you're doing this math, I would recommend rounding that 33 to a 30 because it's a little easier to count up by. You can count up by 3s, and that's the same thing as counting up by 30s. 30, 60, 90, 120, and so on. You're going to find out that 33 can go into 175 times. And if you were to work out 33 times 5 off to the side, you would get 165. When you subtract, you get 5 left over. I'm not done yet, so I have to add a 0 and bring it down. 33 can go into 50 only 1 time. 33 times 1 is 33. When I subtract, I get 17 left over. Bring down a 0 so I can keep going. There hasn't been a pattern established yet. 33 can go into 170. I did do this already, which makes my math easier. 33 times 5 gives me 165. And when I subtract, I get 5 left over. Add a 0 to bring down. And I get 50 again. What you should notice is I started with 170 at the top, then had 50, then 170, then 50. And I know that 33 is going to go into that last 50 one time. Let's just double check. I still get 17 left over, which means if I brought down my 0, I'd be asking to how much to go into 170 again. That means I've established a pattern. 17 over 33 as a decimal is 0.51. And the 5 and the 1 were both repeating, so the line goes over both. I am only writing the numbers that repeat, which is just a 5 and a 1, not more than that, and I'm writing the line over both of them. So 0.51 repeating. Make sure you check these notes in with your teacher and ask any questions if you have them.